So the problem that we are solving today is n queens 2, question number 52, and it says the n queens puzzle is the problem of placing n queens on an n cross n chessboard such that no two queens attack each other. So how two queens can attack each other? Let's see that. If two queens are in the same row or the same column, they can attack each other. Even if there is any other queen on the diagonal position of one queen, that can also attack it. Assume we are in this case, our queen in first row is at third position. So any other queen, if it lies in the diagonal position, that is these orange boxes, then it would be an unsafe position for the other queen. Okay, so our approach will be solving this using backtracking. So what we'll do is, first let us assume this is our first position for queen 1. For the first queen, it doesn't matter where we can keep it anywhere, as it wouldn't have any unsafe position. Unsafe position would be for those queens that lie on the foremost levels, that means the upcoming rows. Now assume a queen was already here, and you can draw it. Assume a queen was um, yeah. Assume a queen was already kept here, and another queen came here, so it would lie in the same row. So this should not happen. What if the queen comes here? Then also it would be an incorrect case. So we don't have to keep it here too. So if it comes here, this is a valid position, and no need of going to next place since we have already found the safest position for queen 2. Now coming to third queen. Third queen is here. They are coming the same column, so it wouldn't be a safe position. Similarly here it comes on the diagonal of this queen. Here it comes on the same column, and here also it comes on the diagonal position. So in such cases, we'll backtrack from a position. That means we'll come to the previous row. This is where backtracking comes into play. We'll come backwards and we'll remove queen from here and take her to the next level. Then again we come to queen 3. We keep it here, not possible since it's same column. We can keep it here because it is not on the diagonal, not on the diagonal of this one also. So we can keep it here. Coming to the last row, we can't keep it here, it comes in this column. Similarly, this strikes it, and if we keep it here, this will strike it as it is in diagonal box. If we keep it here, it comes in this column. So we won't be doing this. We'll be again backtracking. One step back, our queen comes here, but then it strikes it again. So we will go one step more forward. Then also it strikes it. That means we have to again backtrack. Now you can see queen 2 comes on the last position of second row. So we don't have any valid position for queen 2 as we have already tested these three. So we'll backtrack and bring queen 1 to the second position. Now again we'll try for queen 2. No, not valid, not valid, not valid, valid. For this queen it is valid. For this queen not valid, not valid. This is valid. So this is one answer. Focus on the red boxes, not on the screens. So this is our valid arrangement. So how we can do this is, let us start with it. So we are doing backtracking. So let us take an helper function. Helper function will accept this n refers to the number of rows and number of columns that we are having. So for now, let us take that. And last, it is asking us to return an integer. We can do two things. We either pass integer to it and would it would be incremented in our helper function, or we could maintain it globally too as answer equals 0. And and at last it would be returned. Or we could maintain a global variable answer and we'll return it here directly. So as you can see at each column we determine the safest position for a queen by checking if it comes in the column of another queen, the diagonal position, or the row. So for that thing we have to maintain some sort of storage so that we could store which queen occurred in which column before us. So that would be done using an array. Let us say its name is position, and int position equals new int and its size. And in the constraints it is given that n can be at max 9, so it is take 9 or 10, nothing, doesn't matter much. So we could keep it 9 too, but for this it is a small case, so we can take it 10 also. So we have to accept n, and for each row we'll be checking the safest position based on the previous row. For that thing, so to access the index of queen in the previous row, we should have some sort of pointer which tells us in which row we are right now. So by default, we accept the first row, zeroth row as an input from the user. And this function helper won't return anything. Yeah. So I'll say this, what is this answer now? So this answer variable stores the number of such perfect perfect arrangement of means that is possible on a grid of n cross n. So we'll say if this answer, uh, not answer, we'll say we if such a case arises where our row, that means the number of rows, we have traversed all the four rows. That means our row has become equal to n, because this is zeroth row, first row, second row, third row, and fourth row. N is 4 for this. So we, based on the indexing, 0 to 3 the rows go, and if row becomes 4, we'll say return the answer, no, only return, as this control would come again to this function at last and will return the answer. But note that when we increment the row and pass on from the third row to the fourth imaginary row, which isn't there, we are returning. But before returning, we should increment the answer, as since we have found a valid position for queen 4, then only we are coming out from the what we should say in this grid. So after that, how we are storing the elements in position. So position is stores index 0 to 9. So and 0 to 9. So we'll store it somewhat like position of position of some index. We provided row because a single row won't have multiple queens, but a single column may have multiple queens. That's why it's more important to store the index of column. That's so we have taken a one D array, and taking its index as row, we are storing the index of the column at which the queen is present. That means for each queen, I will match all the column indices and match and would look for any other queen that has previously come, not foremost. The previous part should be checked. So since we are involving row and column both, both the row and column variables. So the outer, what we could say, the outer loop should go over the values if let us assume if we are taking for row as the outer loop. Each row we are checking the individual columns, but not. We don't have to do this. We have to check each row for one column. That means column value remains static and row should hover over the rows. A row pointer should hover over the rows. That means we for the four rows, column variable remains static. So that means it has a single value. So column would start from 0, and while column is less than, for now see, we have to move over all the columns. So columns would be less than n, and we'll simply increment the column, and inside that we'll have a row starting from 0 until row is less than. Now make sure we have to check for the rows available before the given queen. So we'll say that when row is, these are previous rows actually. So I'll say previous row equals 0, and while previous row is less than the row, my current row, I'll increase the previous row. Hmm. Now checking if we are at a safe position. Before accessing each row, sorry, each row or at that particular column, I would assume that we are already at a safe position. So I'll say boolean safe equals to, that means I'm safe. That's what I'm assuming. Now I'll check that I'm safe or not, actually safe or not. So to check if I'm safe or not, I'll begin by say checking if position of previous row, this would return a column, is equal to the current column that I'm having. That means in my current column already previously a queen is sitting. Either this is the condition or the diagonal position. This. If this is the queen, we have to look at two diagonals. So in these two diagonals, it's a square matrix. We can clearly see it's a 45-degree angle of slope what it's maintaining with the other queens. That means it's or it's we can say that how should I say it? So the diagonal is 45 degree of any figure. So either its slope will be -1 or +1. Hmm. And slope is y2 minus y1 upon x2 minus x1. If in any case slope turns out to be 1, that means difference in the indexes of x becomes difference in the indexes of y of two queens. That means they lie on the same diagonal. That means slope was 1. That means they both were lying on the same slope. And that if that slope is of 45 degrees, that means they are on the same diagonal, and this shouldn't happen. So we'll say if y2 minus y1. So y will be the column. If position of previous row, that means it's column minus current column. It might be negative, so we can absolute value. If it's value comes in negative, then we are just taking a mod of it, as we are only considered we are considered with the both the diagonals, the this one previous diagonal and the forward diagonal, backward and forward both diagonals. That's why we are taking its absolute value. The y2 minus y1 becomes equal to x2 minus x1. That is the previous row minus current row. Hmm. If this equal, that means we are unsafe. I'll say safe equals false. Since we are unsafe, what we should do now? We should return. Hmm. As we are unsafe, we can't update an index for queen. We are unsafe, that means the previous queen, that means if for this position, assume if we are unsafe, that means the previous queen should update its index. That is why returning, the control will go from wherever this function was called. This would be more clear when we complete this. The other case would be the safe is still true. So I'll say if safe still true, we are already safe in position of row, current row, I would say you please put the column. That means updating my position. After updating my position, means we have found a value for it, we should call the function again, but for the next one, next queen. We'll give n as input with row plus 1. So that's thing, and say false, row shouldn't be increased, we'll return, yeah. Now see, imagine we are with the first row. This queen is standing here. We have just started our function. We come here, column is 0, we proceed, boolean safe equals true. Previous row was already 0. This row was already 0 as we are on 0th row, as the input came 0 from here. So it starts from 0 and says previous row should be less than 0. This won't execute. It would check if it is a safe position. It is safe, that's why we have claimed it to be safe here. Any position for queen 1 would be safe. That's what I told in the starting of the video. So we'll say we'll enter the column index in position array, and we'll call the helper function again for the very next row. Imagine in this loop, while we were on the second row, it somehow fails. We wrote return. This return would bring the control flow back to this previous execution of the where we first row where we called this helper directly without executing this function, as the row was 0. So what would here happen is column was previously 1 when we called it for the first time. Now column will already be 1 as we have returned from second row to this row again. So now column would be 1. So we are setting the position of row to a newer value, which is the next value of column. Again, we call the second row now. Second row again does this. Same for the third, same for the fourth. So that's what is happening here. Let us see if we are missing out anything. Just try to run it and check. It's a compilation error. So previous row should be incremented. Now in the previous output, it gave us an error here. On the Dubai doing the trial run, I came to see that we were doing absolute here, but not here. That's what we were missing out. Let us run it again, and still it gives a different output. Let's go through the code again. If row becomes n, we'll say answer plus plus and return. And if column starts from 0, less than n, column plus plus, boolean say true, previous row is 0, is less than this row, and previous row plus plus, position of previous column is equal to column here, or absolute value of position previous row minus the current column is equal to previous row minus row. That's correct too. Then safe equals false, and we then return. Yeah, if it's still safe, we update the position of row to column. Hmm. Okay. Yeah, and we do helper of n and row plus 1. This also seems to be correct. Hmm. Column 0, column less than n. Boolean safe is true. Previous row is 0, while it is less than the current row. We increment it. If position of previous row is column, or if I do minus, ठीक है, safe equals false, and then return. We are we are not safe, and we should return. Hmm. Actually, we shouldn't return directly here, since the other columns could be a valid value for a safer value for the what should I say, for the queen. So we should try out all these values. If still not safe, the code will come out of the for loop and automatically return to the place from where it was called. So we don't have to explicitly return here. We should say break if we find we should say break if we find a position which wasn't safe, and try out for the next column. If still all the columns get executed and we don't find a valid say a valid or safe space for the queen, then our function will end here. For loop iterations will be finished, and after that we'll automatically return to the place. That means that here for the rows after 1, because the first row was executed from here. After that, all were executed from here. Let us see if it solves. Yes, let us try submitting it. So yeah, it does solve. It is solved.